Hello. So today let's test another model for our Gameboy AI. Last time we tested Devstral and that worked out really well. Today, let's test another model that has had a lot of hype recently. It's GLM 4.7 Flash, and I'm going to be testing it on Q4 Quant, specifically the unsloth Q4, specifically the Q4 KXL Quant. So similar to Devstral, where I had the quantization at Q4, this is the same here, just because I want to be able to fit this all in GPU, which is going to be the 5090. As you can see here, I'm already using almost 30 gigs of VRAM, so I'm pretty maxed out here. Context length is going to be 65 536, which is 64K. I already have everything configured in OpenCode, so we're just going to do the same thing. And I just like to give models a fair shot, so I always introduce with um, you know, get to know the project using the reading the design.md and then read agents files. Just get a summary of what you've done in the past. So let's start with that. Read design md for some project overview, and then read agents.md to see what you have done so far. Warning, not comprehensive. Look over the code base to get more context before we begin. Okay, since it is all on GPU, we're going to have pretty fast inference. The only thing that I am probably wary of is the quantization affecting the performance of the model. But you know what? I think that's fair. If we're going to see whether or not local models perform well on local hardware, they have to be in a state where they can actually be loaded into local hardware. So let's see what we have here. Okay, so uh, that's just this thinking tree. So with for some reason in GLM 4.7, the thinking trace is kind of obvious here. You see the slash think ends it. So yeah, it's going right now. I forgot that it is just like very agentic where it just goes on itself. And I think last time I was like tripping up in terms of thinking that I had to do something, whereas I was just really just commanding the agent on you know what to do. So yeah. Um okay, so here we go. We already have an error. It's some sort of tool call that did not end well. Um okay, so it's reading the entire project. We'll just let it do that for now. And it looks like um it's kind of struggling with opcodes.json because it's big. Yeah, so taking a look at this, I think this is the number of tokens that we've already consumed. We're already at like 60K, I guess. And we're supposed to be maxing out at 64K, so either there's now truncation or there's compaction, whichever. Um, that will probably already affect some of the performance. And remember, 64K on like an 18 gigabyte model on 5090, that's already it's already blown by. Noted about the dispatch table, and so it's figuring out the format. Um, yeah, it's basically trying to just read the code and understand. It's already made a mistake with the grep syntax. So already I can tell that this thing is not as good as Devstral. So now it's claiming that there's a lot of inconsistencies, but I think let's see, particularly around instruction register pair manipulations, where BC appears both as increment target and potentially deck at 90, which seems misaligned with standard Game Boy instructions. Let's see. The dispatch handler is for specific operations. No op is present for byte 0. Inc. BC handler suggests a structured pattern of incremental instruction handling that needs careful verification across different memory locations, like line references to verify the actual implementation status and source code base or testing framework. So many bash errors. Let's see here. Yeah. So this is just its internal monologue, I think. And then now I think it's starting to just figure out what we have done. Yeah, it's saying that we're missing a lot of these types of things. I can carry errors with bash commands in this format. Let me try a different approach. I'll use the glob tool to find handler files. I'm not sure if this is going to be worthwhile at all. The function says LDBCA, but it's actually storing from source BC to destination. Let me reread. Looking more carefully, LDBCA, load A into memory address BC. So LDBCA does a store operation, not load. Okay. This naming is misleading. Second operand seems like it might be coming from, but actually goes to indirect location. Load A into memory address in BC. Yeah. The standard Game Boy instruction set shows LD parentheses BCA, which means load register A into memory address specified by BC. This is a store operation, not reading from BCA. The function name seems reversed compared to typical convention where the first operand indicates source and second denotes destination. Oops. Here it appears backwards. Fine. Maybe. Looking more carefully, LDBCA CPU with parameter CPU. Then inside we're taking registers A value to memory at BC address, not loading from BCA. The name is okay, so it's already starting to repeat itself. I need to verify whether this function actually loads data from one location or stores it somewhere by checking how operand values are structured and what gets written where. Okay. Okay, so I think it was just kind of just talking to itself. It seems like it gets it now, most likely. Um, okay. Let me just quiz it a little bit. It's like any problems you see with the LD implementation, since it was like stressing out about that. Any first, I noticed you were struggling to understand the LD implementation. Do you get it now? It could be that we were wrong to begin with, right? But I just want to make sure that it can see these little details. So I hear the GPU just like working right now. The fans are going pretty loud. Okay, so the user pointed out that I was struggling. Let's see. Let's finish the thinking part. I think it's still thinking. Okay, I think I triggered something. It's just like the results here is okay, so you're right. I didn't fully notice that some ink operations are being handled within LD handlers.py. Looking at it again, pattern makes sense. Okay, so it basically is okay with how we're doing things now. Okay, so what's the easiest add or sub instruction you think you can implement? Let's just do one right now to test to see if you can adhere to the coding styles and specifications. So let's ask. Now it's done thinking. So looking at what's already implemented versus the test file. All inkdeck instructions are done. ADC operations tested, but handler not likely yet in place. No basic add sub accumulator found. The simplest addition instruction would be adding a single byte from another register directly into A, okay, or similar. So basically adding a value pointed at that specific byte into What into A, but it's add B. Oh, maybe add B and this value, and then store it in A automatically, most likely. Let's see. Hmm. So let me add a handler. Let me add the handler to handlers directory and update dispatch table and test. I made an error. I need to write actual code, not pseudocode and constant middle lines of incomplete sentence. Wow. Okay. So looking at ADC pattern, I need to get the source operand from register via get register, add both values together, including carry flag, set 0 if the result is 0. Okay. You know what? I don't know why it's claiming that because handlers already has the add with carry. This is add what? Oh, add. Okay, so is there an add instruction? Let's see. So, let's see, Z80, add and ADC. Okay, so now, is there such a thing called add? Yes, there is. So add, okay, we have all these basic adds here. So it should be able to do them. Um, Whether or not it's going to be effective, not sure. So let's see. Okay, so it's really struggling. So I'm stuck in a pattern of writing pseudocode. I need to provide actual working code. Wow. I'm still writing pseudocode in the comments. It's causing LSP errors. Okay, I think we have enough. I don't want it to ruin this project. It's horrible. Sorry, I don't know what's wrong with GLM 4.7 Flash. Again, I'm coming at this from like a newbie perspective. If I'm getting this type of experience already with this model, it's to me it's not a good coding model. I'm done. Let's salvage this and go back to Devstral and see how well it does. And then now let's just undo all of this. This is not good. Okay. So now let's go back to Devstral and see the difference. So Devstral with my default stuff. And then hopefully it can do something. Again, I'm going to kind of just give it to design.md and agents.md to just see how to go, like just understand the project and how to go from there. Okay, so all loaded. Let's do it. Let's see where we can go from here. Open code. Now let's switch models. Oops. Switch models, Devstral. Okay. Take a look at design.md and read over agents.md to, I guess, calibrate yourself on the project. Let's discuss on the next step after you are done. Last time we left off, we were implementing some arithmetic operations. I'm just giving it that free thing because I had a horrible time with GLM just now. And let's see how well it does this time. Okay. Devstral is already off and running. Okay. Look, it's like really good with running tools. It's ridiculously good at it. It's like it doesn't have as much trouble. Wow, look at this. It's like night and day. I really just maybe we should just stick with Devstral. So there are no add handlers yet. So notice that. So okay, it knows the current state. So okay, implemented all the ADC. Now we need to add instructions. Um, okay, since they're fundamental arithmetic operations, What do you like to work on next? Add HLX are Good's next step as they're simpler than implementing all the A registers arithmetic ops. Yeah, let's do it. Yeah, let's do it. Stick to the usual coding style, add tests, and just make sure things pass and don't make shit up. Okay. Um, I guess it's gonna try to do all of them in one go, the add HLXX operations, which is okay, I think. So all add HL operations have the same behavior. 8 cycles, takes in consideration N flag, H and C flags are affected based on carry, half carry from addition. So half carry flag and carry flag, and Z flag is not affected, meaning it's just hyphen means unchanged. Now let me implement these handlers, preparing edit. Okay, it's going. Very intelligent. It's already using 60K context, but that's okay. Compaction will occur. And it's just going. Look at that. 1, 2, 3, 4 opcodes already implemented. And I just get to kick back and relax. That's how good Devstral is. When people say, "Oh, this is like sonnet level or whatever," I think for like my use case for this project right now, it's definitely fulfilling that need. Like, have just it makes open code really easy to use. Um, wow. Okay. Yeah, that makes sense. It was generating a lot of tokens just now. Let's see if they actually pass. So all of them seem okay. Well, at least the ones that it has implemented. Oh, okay. So it's just writing one test at a time. Writing and running one test at a time. Is that what it did? Yes. Okay. So individually, I think it's doing that so that if something fails, it can at least debug, which is pretty smart. This is excellent, an excellent experience. Sorry, I'm just going to stick with Devstral for now. I was hoping that we could do this like head-to-head showdown, but I don't think there's a competition. I'm guessing if this was like a web project, maybe GLM would have done better. Okay, so it looks like all 112 tests pass. Okay, now including the new 6th one, let me update the to-do list. Okay, tasks completed. Great. Now any other add instructions to implement? Let's do that all in one go. Seems like you know what you are doing. Okay, so let's just have it do every add instruction right now. We'll check back, but basically there was a remaining group that had to be implemented. I believe it was where was it? Here, add a XX. So that's what it has to implement next, and I'll just have it do all of it in one go. And yes, it recognized that it's doing that right now. So I think I said great. Now add any other add instructions to implement, and then it's probably just going to go and do that. Okay, so now it's okay. So it's struggling, but then it figured it all out, and it's going to just implement all of these. Cool. All right, we'll let it do that, and we'll come back. Okay, so it looks like it's found some bugs with its own implementation, but it's just trying to fix itself right now, and I think um, it's starting. It's figuring it all out basically. It seems like it's doing well. Uh, so it's trying to check all the logic, and I think a part of this has to do with probably the context length, the context window that I put. Um, and I think like if I had probably specified maybe like 80K context, it probably would have been able to kind of keep all that and use that as reference as it's implementing things. I'm just making stuff up. I really don't know. At the end of the day, it's only like a 24 billion parameter model, so it's not like expectations. There's expectations, right? Like you have to keep them very tempered. But I think it does very well for a 24 billion parameter model. Okay, all 123 tests pass. So update the to-do list and agents.md file. And cool. Now I'm going to do something risky, but let's commit and push first. And yeah, I think if you are to run like a local coding model, it definitely has to fit all in GPU. I just feel like um uh offloading is going to be too slow. The fact is that this is a 5090, everything's already in GPU, and yet I'm still getting kind of like a lot of these hitches, not hitches, but like moments where it takes quite a while to do things. I'm not used to that if I'm using like a cloud-based model. So I cannot imagine like offloading to CPU. It will just be too slow, especially there's so many tokens to process. Um, just be very, yeah, I don't think the experience would be that good. So I do have like a janky RTX Pro 6000. It locks up once in a while at higher power draws. Thinking about just testing that one too. Swapping out the 5090 for that RTX Pro 6000 and see how well it does with like Devstral will do with a bigger context length. Okay. Huh. What is it doing right now? I think it's trying to. Oh, it's just trying to see if there are any other add instructions to implement. Yeah, not much of an exciting video, I know, but I think it just kind of shows us at least some real world agentic programming that isn't uh with the expectation of one shot or zero shot and uh like what having it be like a web page. I don't even know if the CPU actually works anyway to begin with. We'll see. Okay, already a duplicate entry for 0x80. Let me check the full dispatch table to understand what's happening. Okay, so there are duplicate entries. Let me check the context around line 145. Okay, there are two separate dispatch tables, one for add and one for ADC. The ADC table is commented out or not being used. Let me check if the ADC handlers were imported. Okay. Uh-oh. I guess we're gonna have problems now. Okay, so it says the ADC handlers were imported but not used in dispatch table. That's weird because I remember we did use them. Let's see. GB CPU. Um, Perhaps we didn't save them. Yeah, they're right here. Weird. Oh, they're starting to conflict. Interesting. So, what is the difference between ADC and add? Because in this case here, um, allow instructions. So these are all the add ones, but we want to know the opcodes for them. There's also ADC ones too. So now I'm starting to like wonder if we should actually trust um, the LLM because we already confused uh, two instructions in their opcode. So let's see. Is there any reference in terms of the opcode numbers? No, these are just tutorials. Z80 instruction set. Okay, so here opcode ADC. Let's just look for ADC. Oh, this is confusing. There was like this table. I think we had it somewhere here. Um, Is it specification? Yeah, no. Hmm. Opcodes.json. Yeah. So there's a 0x80. That is add. So it did that one right. So where did it get ADC from? 0x88, 0x89. So starting from 0x88, this one is. Uh-oh. Is it fixing things? Oh, yeah, it is fixing things. Oh, great. That's cool. So it is starting to fix everything. That's impressive. So realized it. Okay, so it's adding it all back. It's probably going to try and lit or add ADCA and 8. Okay, so it's importing that now. Interesting. There was something wrong before, but it fixed it. Okay, so if it doesn't exist yet, let's see if it will try to implement it on its own. Well, okay, fine. That's the right thing to do. We haven't implemented it. It'll probably ask to implement that. Or it'll probably do it by itself. Let's see. So I think after this, I'm going to say, are we missing any ADC or add instructions? And then just have it just implement that. Okay, so the ADC tests are failing because they're using opcode 0x80, which is now add AB instead of 0x88. Let me check one of these test files, see what's happening. Okay, that's cool. It's doing the right thing. It's probably going to fix all that. I wonder what's HW Info 64. I wonder what our sensors are like, because I feel like it's really hot right now. Let's see what it is. Let's see. Sensors. Looks like our GPU is going to be. Come on. Whoa, memory junction 86, GPU temperature definitely. Yeah, that feels like it. I feel it on my leg right now because the computer's on my floor. So definitely feeling it. Let's see where the CPUs. Oh, DIMMs are running pretty cool. That's fine, which makes sense. CPUs at I guess 71 right now, which is true because it has like a really bad cooler. Um, it has that cooler master cooler I put in like a year ago when we were uh, installing the 10 torrent card. If the tests are wrong, they should be using 0x88 to 0x8F for ADC. So I wonder if we can also like just have it implement all the subtraction operations on its own, and then we can just check back and see what ends up happening. So after this, after it fixes and gets to a good state, we're going to commit, and then we're going to do that exercise. And I think at this point, I think it could probably just implement the entire CPU. So now it's adding it. And maybe I'll install the RTX Pro 6000, even though it might freeze up on me, lock up. Uh, but it will allow us to have a bigger context window. And if it doesn't lock up, we have a better experience. If it locks up, then oh well. I think the issue is just more like it needs a proper VBIOS. Probably had to get it directly from uh was the manufacturer PNY. Okay, so I think it modified the tests and no, it's just testing add. But what about ADC? It's doing it one at a time again. Yeah, this should probably show like total tokens used, not just like in the context window. I wonder if I can see that. Let's see here. No. Okay. Oh, wait. Is there like session info? View status. Yeah, let's do view status. No, these are just okay. Never mind. Okay, still going. All right, let's just check back. I think it's gonna do this. So it was trying to make sure all the ad tests were passing. Now it's going to try and fix all the ADC tests. So there were no ADC handlers in the previous commit. That means someone or probably a previous AI agent added both. Oh, what is it? Added both ADC, add and ADC handlers or put them in the wrong opcodes. The tests for ADC were written assuming 0x80 to 0x87, which is wrong. Since I've fixed the dispatch table using correct opcodes, I should update the test to match. However, let me first check if there are any other ADC or add or ADC implementations we need to complete. So it's searching. Okay, cool. So it's actually going to finish up all the ads and the ADC. So that's okay. So it's like gonna do that first, and it's like okay, let's do that first, and then let's just fix all the tests as one go. So, uh, wow. Okay, let's just leave it alone and let it do its thing. We can check back later. Alrighty. So Mistral, or sorry, not Mistral, Devstral ended up figuring out how to fix all the add and add with carry instructions, fix the test and everything. So now it's asking if if we're going to allow it to implement the sub operations. And before we do that, let's actually commit and push first, and then have it implement all the subtraction stuff. So you know what? Let's commit and push this good work first. And then let's implement all these subtraction related operations in one go. Make sure we have some good tests. Okay. So let's see what it does. It should commit and push, and then it's gonna probably spend the next, I don't know, 15 minutes doing all this subtraction implementation, which I think is still way faster than if I were to do it as a human. Of course, I could just like end up copying, pasting, and things like that, but it's just more convenient to have it just run in the background while I do something else. So yeah, in reality, every time I'm pausing, I'm just going off and doing something else at the same time, and then I just kind of pause the OBS recording and then just come back to it later. So everything else here has been committed. And then now what we're going to do is we're going to just let it run wild pretty much on implementing all the subtraction stuff, ensuring there's tests. And then after that, let's get some guidance on what other easy instructions are left. At this point, I'm just going to commit to Devstral until it fails on me. Then we'll go seek for another model. But this thing has been pretty good. Okay. Preparing to write. What does that even mean? Okay, there we go. Okay, so it's just going to do all. Okay, oh, I see why it's a lot. Okay, let's have it just do all that and then figure out all the tests, and then we'll come back to it later. Okay, so the model finished implementing all the subtraction stuff. We can check it out here in the arith handlers. A bunch of subtraction things. Um, there's also a lot of tests now implemented, and all of the tests are passing. Now we are up to 143 CPU tests. So at this point, we can just have it just run the test one more time, and then let's get commit and push. So can you run the tests one more time just in case? If all are passing, go ahead and commit and push. All right, let's see. Ran all 143 tests in 0.136 seconds. Okay. And now let's commit and push. Cool. Git add A. Now, after this, I want to do something different. Like I'm going to stop right here, but I think something different to do here is to say, okay, now write your plan for what we need to do the next time around we work on this because I think we're done for today, kind of thing. So that's what is next here. So it'll update the agents.md file most likely, and then we can go from there next time. My hope is that okay, maybe we can give another model another shot, but just like kind of go directly into like the agents.md file. Okay, okay. Now, what do you think is the next easiest set of opcodes to implement? Let's table implement off implementing them right away for now, but instead update uh, agents.md file for you to remember where to pick up off from next time we work together. I am about to sign off after this, so I need you to just put us at a good state. Okay. Yeah, I also like this model because I don't need to type properly. I just type how I'm speaking in my head. And so let's see what it's gonna add. Cool. So it's add next steps. Okay, so the next easiest set of opcodes are basically the bitwise operations. I think we can also just do all of it in one go. And yeah, it it has developed this pattern in how to work in this repo so far for the CPU. So that's good. So commit and push those agent MD changes. I'm actually really happy with uh, Devstral again. Okay, everything is committed and pushed. The project's in a clean state. Goodbye. Okay, good. Good, we're good. All right, thanks for another session with me. I know that was kind of boring because I think what I was expecting was like a heated comparison with GLM 4.7 Devstral 2. But based off of this experience, there's no competition. Maybe I need to update something, but I already have Elm Studio update to the latest along with Llama CPP. So I don't know. We'll see. Anyway, thank you. Okay, let's continue on. Let's continue our implementation of this project. Nice. Okay, based on the agents file, here are some options. let's let's do them all. Let's implement all the bitwise operations. Let's do them all. I trust you. You have been great. Implement the AND or XOR and CP bitwise operations. Stick to the coding style. Be conservative. Write tests. Make sure they always pass. Do your best. Do your best. You can do it. Let's see how it does with this. And then let's bring in hardware info 64. Today I just want to just code for fun and have some fun. Not going to be talking as much, so um, if you're looking for anything super insightful, oops, probably not going to get it. Okay. Just you're just gonna be watching me doing stuff on the computer, basically. Okay, so it looks like metrics look okay. Um, maybe I should just stop like showing these things because I really don't care about them. Okay. I do care about my dims. Cool. So, GPU right now is about 70. Um, Not too bad. So now, definitely Devstral is working. We are about 15K tokens used. What else can we do? It did it all. Crazy. Okay, did it create a new file or not? Let's see. Hmm. Arith handlers. Does it make sense for it to be in the arith handlers? I want to ask it that later. Um, is it considered arith handlers or bitwise handlers? Okay, that doesn't look good. It looks like maybe there was just too much context. If I look at Home Studio, maybe this no. Okay, so something happened. I think it was an invalid tool call. So I'm gonna call it out, say, hey, maybe that was too much data into the tool call. Let's do a little bit at a time. Hey, that tool call failed. Let's actually oh it seems like you were trying to do too much at once. Can you break down your test updates into multiple iterations? Also, do note that I am not sure that it makes sense to put all the bitwise handlers into arith handlers. Perhaps maybe we can create another file for this. Okay, let's see what happens. So technically we're like at max context already. I think we should have, I don't know, I think it should have compacted, but let's see. Um, I'm amazed that it's actually still coherent though. Okay, let's see what happens. All right, so it looks like the model here has figured out to put all the bitwise operators most likely into its own file. Let's see here. Yeah, bitwise handlers, and it looks like it removed a bunch of stuff. Um, should have been able to add it to the op handlers, but here they also moved things to the bitwise handlers um, file. Now I'm thinking that it might be struggling because it forgot to add things to the op handlers most likely because I didn't see any code changes for that. Um, let's see here. Okay, there's a problem how the handlers are accessing operands. Uh-huh. Okay, sure. Let's see. It's struggling because there was a lot to do. And maybe I shouldn't have done that. Yeah, I think the key with agentic coding agents that we had to do it a little bit at a time. So, oh, now it has to update tests. Wait, let me fix the bitwise handlers file. Okay, or a and 8. Okay, so now it has to do all of that, every single one of them. And my GPU is going crazy, but it's okay. So let's give it a chance. This is a bigger job than what we've given Devstral in the past, so I'll be very forgiving. And if it does eventually nail all of this, I'll be very impressed. Um, GPU is struggling, 82C right now, which is probably not healthy for a gamer card, and I do feel the heat. So I'm going to pause and pop the side open of my computer and hope that it's enough cooling still to actually keep everything okay. So let me do that. Okay, so I literally just like took the side panel off of my computer, and amazingly, it's back down to like 74. I'm using that fractal case that I've been using all the time, and it's like one of my favorite cases, but it seems like that doesn't really give much airflow. So Um, whatever. It's okay now though. So it's been just fixing some bugs. Um, let's see. Okay, cool. Whoa, we did it. Let's see. Um, yeah, okay, well, we'll test one more time, just in case. Whoa, it actually did all that. That's interesting. Let's see if it's actually right. Bitwise and of A and result into A. Okay, that's kind of obvious, but still, I'm impressed. Update flag Z is going to be 1 if result is 0, and it's going to be always false. This one is always going to be true. Okay. I'm going to trust just by spot checking. It at least knows how to code a little bit. Okay, all of them pass. Okay, commit and push. Impressive. It handled that okay. That was really tough on my GPU. Okay, update agents.md file, and what are the next set of easiest opcodes we can implement in your opinion? I think Devstral is really good with instruction following. I've noticed that. Okay, so okay, is our fine. Agent's MD file is already up to date with the latest implementation details. Based on our current progress and patterns established, here are the next easiest set of opcodes to implement. So rotate shift, LDR1, R2, so register to register transfers, LDH. Okay, so I'm not gonna make the same mistake. I think it's going to struggle if I give it too much. So let's just say, okay, now let's work on rotation and shift instructions first. Okay, so let's start with rotation and shift instructions first. Let's not go. Yeah, let's just start with that first. I think you know how to code within this repo. Great job in struggling and figuring things out earlier. Okay. I think if it is smart enough, it'll try to create a new file. Thank you. I appreciate your encouragement. Let's tackle the rotation shift instructions next. These are great follow-ups since they're similar in complexity to the bitwise operations we just completed. So, yeah. Add adder. Okay. So let me research the rotation shift instructions based on Game Boy CPU documentation. Here are the rotation shift instructions to implement. Okay, so I don't really trust that because it has like no real like um what is it? No real reference, right? But one of these days I'm going to like say, okay, here, hey Claude, here is an entire Game Boy CPU implementation vibe coded from Devstral. Check it over and see how wrong it is. So maybe I should do that eventually. But I'll also give Devstral a chance to like kind of like check every single part over. Okay, so did it create a new file? Is it smart enough to do that? I hope so, please. Yes, rotate handlers. Great. It's smart enough to do that. Open code is still working on this. I think it's just finding issues on its own new code that it has written. So the rotate stuff. That's okay. I'm more concerned if it found bugs on the old stuff. It means that now I can't really trust the thing. But if it's just on its new thing, then I'll take it. Still working on it, it looks like. Um, it's I think it's working on something else now. I think it is now working on. Oh, it's just trying to fix its tests for shifting. It looks like. Okay, and it's trying to fix its algorithm. Okay, let's let it figure it out. Okay, so code is still working on fixing things and fixing tests. I hope it's not stuck or anything. It looks like there is activity. Okay, so there's progress and activity. That's okay. Um, what else do we have? So it's writing the test now. Okay, so typo on the test. The input value should be 0xc9, not 0xca. Let's see. Whoa. It looks like it's struggling a little. All right. It seems like the model is starting to struggle. It can't even like figure out the right test names, it seems like. It's been going for a while. Let's see. Okay, well, not much to do but wait. I think the lesson here is like, um, maybe I could have just implemented it again. Like maybe I could have just implemented this myself. But then I would have to read all the spec and things like that. And I'm just more like the whole purpose of this project was I wanted to create like a autonomous Pokemon playing agent, but like do it all from like zero. So I wasn't really interested. I was not interested in developing the emulator. I was just hoping that an AI could just do that. Um, so yeah, this is interesting, but okay. Um, and notice that the system is getting slower. In this case, ooh, what's going on? Okay, probably generating tokens. Yeah, it's generating tokens. Okay. So let's just leave it be and then hopefully it'll find its way. Wow, that took a while, but it did it, I guess. Rotate shift instructions are done. Um I think it has created more tests, so let's see how many tests it claims to have written now. Okay, so it says all 10 rotate tests. So it created a new file. Now I'm gonna have it run all the tests. Oh, all 191 CPU tests pass. Okay, great. The implementation follows established patterns. Okay. Um, let's push it. Let's have it now do the load ones. Okay. So now commit and push. So it is getting slower, but it is working. But it found its way out of bad situation. Um, yeah, it was struggling for a long time fixing all these things, but it actually did it. I don't know if it's actually true, but let's see. We will see. Again, I think I'm gonna have like Claude eval all of this. It's like, is this like, is this like, what is this? Find all the bugs or whatever. Here are the tests. Let's have both like Claude, Gemini, and was it GPT do all of that? Like a challenge for like which one can find the most bugs written by Devstral. Okay. Now uh, let's implement the rest of the LD operations. So I'm still surprised that I can do this on a Core i7 13700 and with just a 5090. So this is very surprising, actually, if this is all True. Okay. So it's checking which operations are still missing. I I did I didn't check though if it is actually updating the opcode table. Is it? See, yeah, it did update the opcode table. That's okay. Cool. Yeah. Okay. Um. Hmm. Wait. These tests were already failing before. Why? Wait a second. Okay. First, let's force it to fix all the tests. It says all tests were passing. Now it says tests are failing. Okay, it's adding a lot of handlers again. I didn't think it would be this much, but okay. We'll just wait for it again. All right, so this is all right. So supposedly it's done, but now I'm like, you said the tests were failing before, so now I'm gonna make it run the tests. Okay, first you need to run the tests, the entire suite of tests again and make sure they all pass. We cannot accept test failures or leaving tests in a state where they are not passing. So it was a more, I think it implemented more, I think a total of 16 more instructions maybe. That's why it has 16 tests. But this definitely looks more. Let's see. Okay, so I see there are 3 pre-existing test failures. Let's me check if the tests are failing before it changes. No, I don't care. Like, to be honest with you, you're working on this repo with me. You're responsible too. uh, so let it do that thing. Okay, so apparently the handlers are imported but not registered in dispatch table. Really? Let's see. There should be like some, I guess, like faded out text somewhere. Right here. Ah, I see. Maybe, yeah, maybe because of all the find and replace and all that stuff that it does. Okay, we'll just let it go. Okay, imports are there. Check to see if they're registered in the dispatch table, which they are not. They're going to have to be. The handlers imported are not registered. Okay, well, I could have just added that myself. I mean, that seems like an easy thing to do, but I'm just gonna sit here. I'll do something else in the meantime. Okay, it's claiming that the code base is clean. I just added the up handlers to the dispatch table. Going to make it do it again. Run the test again. run, run the entire test suite again, just to double check. So maybe I didn't check earlier. Maybe it was just running its own test I had implemented for the past few times, and that's why it was like missed. Okay, cool. Um, yeah, actually, now that I think about it, I didn't see this last time. Like this whole like uh test suite command. Cool. Okay. So now let's do this. Let's like update agents.md file to note down what's left to do, easiest things, and we'll continue next time. After that, commit and push. Okay, I think that was a lot of code that I wrote. It did a lot. It struggled a lot, but I think it was a good session because I discovered that it can like at least with Devstral and open code, it can work its way out of things. Getting 24 billion parameter quantized Q4. Overall, pretty impressive. I think a part of it is probably like open code, handling all that agenic stuff, making sure this doesn't keep like it doesn't give up and keeps going. I find that very. I don't really use Cloud Code, so I can't make that comparison. But maybe I should. Maybe I should use it to like do what I've been saying. Hey, take a look at this entire implementation. Okay, and then I think that's it after that, and I'll continue next time. Uh, Not much interesting things this time around, except that we discovered uh, Devstral's pretty good at getting itself out of bad situations. All right, so what does it say? A completed work. Okay, commit and push. Whatever. All right, cool. Next time. Thanks. Bye.